Hi there, Science Explorers. Today we're talking about something we experience every single day, heat. From the warm sun on your face to the toasty feeling after a hot meal, heat is a big part of our lives. Understanding heat helps us appreciate how things work, like why we wear sweaters in winter and how our food gets cooked. It's pretty cool stuff. Imagine a hot cup of cocoa on a chilly day. You can feel the warmth radiating from the mug, right? That's heat energy. It's all around us, making our world interesting and dynamic. So buckle up as we dive into the fascinating world of heat. Now let's clear up something important. Heat and temperature are not the same. Think of it like this. Imagine a pot of boiling water and a giant swimming pool filled with warm water. Both have different temperatures, right? The boiling water is much hotter. But here's the catch. The swimming pool, even though it's not as hot as the boiling water, actually contains more heat energy overall because it has a much larger volume of water. So temperature tells us how hot or cold something is, while heat refers to the total energy within an object or substance. It's kind of like the difference between how fast a car is going, temperature, and how much gas it has in the tank, heat. Heat is a traveler. It loves to move from hotter objects to cooler ones, and guess what? It has three main ways of getting around: conduction, convection, and radiation. Conduction is like a game of molecular tag. Imagine heating one end of a metal rod. The heat energy makes the molecules in that end vibrate faster. These excited molecules then bump into their neighbors, passing the heat energy along the rod. That's conduction heat transfer through direct contact. Convection is all about currents. Think about a pot of soup simmering on the stove. The soup at the bottom gets heated first and becomes less dense, causing it to rise. Cooler soup from the top then moves down to take its place, creating a continuous flow. This circular motion is convection heat transfer through the movement of fluids. Radiation is the sun's superpower. It's how the sun's heat reaches us across millions of miles of empty space. Radiation is heat transfer through electromagnetic waves, and it doesn't need any medium to travel, unlike conduction or convection. Section 4. Growing with heat. Thermal expansion. Have you ever noticed that things tend to expand when they get hot? That's thermal expansion. When you heat something, you're giving its molecules more energy to move around. As they jiggle and bounce with excitement, they need more space, causing the object to expand. Think about railway tracks, and they have small gaps between them to allow for expansion during hot weather. Without these gaps, the tracks could buckle under the intense heat. Similarly, bridges and buildings are also designed with expansion joints to accommodate temperature changes. Section 5. Heat. It's a big deal. So, there you have it. We've explored the fascinating world of heat, from its difference from temperature to its various modes of travel and its ability to make things expand. Understanding heat is essential because it plays a vital role in our lives, influencing everything from the weather to the way we cook our food. Remember, heat is energy on the move, constantly flowing from hotter objects to cooler ones. And as we've seen, it has some pretty amazing ways of getting around. Keep those scientific minds curious, and I'll catch you in our next exciting adventure.